Class 2 remote control, signaling, or power-limited circuits are those that have voltage limitations. In heating, ventilation, and air conditioning systems, Class 2 wiring is typically used for low-voltage control circuits, such as those used for thermostats, zone dampers, and other control devices. For Class 2 wiring in heating, ventilation, and air conditioning systems, the specific type of wire used will depend on the specific application. However, some common types of Class 2 wire used in heating, ventilation, and air conditioning systems include CL2 or CL3 cable. This type of cable is suitable for use in heating, ventilation, and air conditioning systems, as it is rated for use in both wet and dry locations. It is typically used for low-voltage control circuits, such as those used for thermostats and zone dampers. Then there is CAT5 or CAT6 cable. This type of cable is commonly used for data transmission in heating, ventilation, and air conditioning systems. It can also be used for low-voltage control circuits, such as those used for thermostats and zone dampers. Finally, shielded or unshielded twisted pair cable is often employed. This type of cable is commonly used for low-voltage control circuits in heating, ventilation, and air conditioning systems. It is available in both shielded and unshielded versions. Shielded cable is used to protect the signal from interference, while unshielded cable is used for shorter runs where interference is not a concern. When selecting Class 2 wire for heating, ventilation, and air conditioning systems, it is important to consider the specific application and the environment in which the wire will be used. You should also consult with a qualified electrician or heating, ventilation, and air conditioning technician to ensure that the wire is properly installed and meets all applicable codes and regulations. Class 2 circuits are defined by the National Electrical Code, or NEC, as circuits with voltage and current limitations that reduce the risk of electrical shock and fire. These circuits are commonly used for low-power applications like doorbells, thermostats, and control systems. The NEC specifies the requirements for Class 2 wiring in Article 725. This article outlines the limitations on voltage and current, as well as the types of wiring methods that are permitted. The purpose of Class 2 circuits is to provide a safer alternative to traditional power circuits for low-energy applications. By limiting the voltage and current, the risk of electrical shock and fire is significantly reduced. This makes Class 2 circuits ideal for use in residential, commercial, and industrial settings where safety is a concern. Class 2 power supplies are designed to limit the voltage and current to safe levels. These power supplies are typically used in conjunction with Class 2 circuits to provide a complete low-power system. Class 2 power supplies must meet specific requirements outlined in UL 1310, the standard for Class 2 power units. These requirements ensure that the power supply is capable of limiting the voltage and current to safe levels under both normal and fault conditions. There are several types of Class 2 wiring methods that are permitted by the NEC. These include CL2, CL2P, CL2R, and CL2X cables. Each type of cable has its own specific characteristics and is suitable for different applications. CL2 cable is the general-purpose Class 2 cable and is suitable for use in most applications. CL2P cable is plenum rated and is suitable for use in air handling spaces. CL2R cable is riser rated and is suitable for use in vertical runs in buildings. CL2X cable is limited use cable and is suitable for use in dwellings and for short runs in other locations. When installing Class 2 wiring, it is important to follow the requirements outlined in the NEC. This includes using the correct type of cable for the application, properly supporting the cable, and making sure that all connections are secure. It is also important to avoid running Class 2 wiring in the same conduit or enclosure as power wiring. This can help to prevent interference and ensure that the Class 2 circuit operates properly. Class 2 circuits offer a safe and reliable way to power low-energy applications. By understanding the requirements for Class 2 wiring and power supplies, you can ensure that your low-power systems are safe and compliant with the NEC. Remember to always consult with a qualified electrician or electrical inspector if you have any questions about Class 2 circuits or wiring. Additional details concerning Class 2 wiring are firstly voltage limitation, which is typically 30 volts alternating current root mean square or 60 volts direct current. Secondly, power limitation, which is generally 100 volt amps. Thirdly, listing and marking, so Class 2 cables and power supplies must be listed and marked for Class 2 use. Fourthly, separation from power circuits. Class 2 wiring should be physically separated from power circuits. Fifthly, overcurrent protection. Class 2 power supplies must have overcurrent protection. Sixthly, ampacity. Class 2 wiring must be sized according to its ampacity. Seventhly, support. Class 2 wiring must be properly supported. Eighthly, termination. Class 2 wiring must be properly terminated. Ninthly, inspection. Class 2 wiring installation should be inspected to ensure compliance with the NEC. The National Electrical Code, or NEC, defines different classes of wiring based on their voltage and power limitations. Class 1, Class 2, and Class 3 circuits each have distinct characteristics and applications. It is important to understand these differences to ensure proper wiring and safety in electrical installations. Class 1 circuits operate at higher voltages and power levels compared to Class 2 and Class 3 circuits. They are typically used for power distribution, lighting, and motor control. Class 1 circuits are subject to more stringent requirements in the NEC, including overcurrent protection and wiring methods. Class 1 circuits can have a voltage of up to 600 volts. They are used for general-purpose power and lighting circuits. Class 1 circuits require more robust wiring methods and overcurrent protection compared to Class 2 and Class 3 circuits. Class 2 circuits are characterized by the limited voltage and power, which reduces the risk of electrical shock and fire. They are commonly used for low-voltage applications such as thermostats, doorbells, and security systems. The NEC specifies the requirements for Class 2 circuits in Article 725. Class 2 circuits typically have a voltage of 30 volts alternating current or 60 volts direct current and a power limitation of 100 volt amps. They are designed to be inherently safer than Class 1 circuits due to their low voltage and power levels. Class 2 circuits require listed Class 2 power supplies or transformers to ensure that the voltage and current are limited to safe levels. Class 3 circuits, similar to Class 2 circuits, have voltage and power limitations, but they allow for slightly higher voltage and power levels. They are used for applications where more power is needed than Class 2 circuits can provide, but where safety is still a concern. The NEC also covers Class 3 circuits in Article 725. Class 3 circuits typically have a voltage of 150 volts alternating current or direct current, and a power limitation of 0.5 volt amps. They are used for applications such as remote control and signaling circuits. Class 3 circuits require special wiring methods and overcurrent protection to ensure safety. In summary, Class 1 circuits are high-voltage, high-power circuits used for general-purpose power and lighting. Class 2 circuits are low-voltage, low-power circuits used for applications where safety is a primary concern. Class 3 circuits are intermediate voltage and power circuits used for applications where more power is needed than Class 2 circuits can provide. When selecting the appropriate class of wiring for a particular application, it is important to consider the voltage and power requirements, as well as the safety considerations. The NEC provides detailed guidance on the requirements for each class of wiring. Consulting with a qualified electrician is always recommended to ensure proper wiring and compliance with the NEC. In heating, ventilation, and air conditioning systems, the choice of wiring depends on the specific application and the voltage and power requirements of the control system. Class 2 wiring is commonly used for low-voltage control circuits, such as those for thermostats and zone dampers. However, Class 1 wiring may be required for higher voltage components such as motors and fans. When working with electrical wiring, it is important to always follow safety precautions and to consult with a qualified electrician if you have any questions or concerns. Electrical work can be dangerous, and it is important to take the necessary steps to protect yourself and others from harm. Also note that CAT5 and CAT6 cables, while sometimes used for low-voltage control circuits, are primarily designed for data transmission and may not be suitable for all heating, ventilation, and air conditioning applications. It is important to check the specifications of the cable and the requirements of the heating, ventilation, and air conditioning system to ensure compatibility. Additionally, shielded twisted pair cable is often used in environments where electromagnetic interference, or EMI, is a concern. The shield helps to protect the signal from noise and interference, which can improve the performance of the control system. Unshielded twisted pair cable is less expensive and is suitable for applications where EMI is not a significant concern. When selecting shielded or unshielded cable, it is important to consider the environment in which the cable will be used and the potential for interference. The type of wire you use for heating, ventilation, and air conditioning Class 2 wiring will also depend on local codes and regulations. Always check with your local building department or electrical inspector to ensure that you are using the correct type of wire and that your installation meets all applicable requirements. Proper wiring is essential for the safe and reliable operation of heating, ventilation, and air conditioning systems. Taking the time to select the correct type of wire and to install it properly can help to prevent electrical problems and ensure that your heating, ventilation, and air conditioning system operates efficiently. Remember that safety should always be your top priority when working with electricity. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to do the work for you. Attempting to do electrical work without the proper training and experience can be dangerous and can lead to serious injury or even death. In addition to the types of wire mentioned earlier, there are other types of wire that may be used for Class 2 wiring in heating, ventilation, and air conditioning systems. These include thermostat cable, which is specifically designed for use with thermostats, and bell wire, which is a low-voltage wire that is commonly used for doorbells and other signaling circuits. The specific type of wire that you use will depend on the application and the requirements of the heating, ventilation, and air conditioning system. When in doubt, it is always best to consult with a qualified electrician or heating, ventilation, and air conditioning technician to ensure that you are using the correct type of wire and that your installation meets all applicable codes and regulations. Proper wire sizing is also essential for Class 2 wiring in heating, ventilation, and air conditioning systems. The size of the wire must be appropriate for the amount of current that it will be carrying. If the wire is too small, it can overheat and cause a fire. The NEC provides guidance on the proper wire size for different applications. It is important to consult the NEC to ensure that you are using the correct wire size for your Class 2 wiring installation. In addition to wire size, it is also important to consider the insulation rating of the wire. The insulation rating indicates the maximum temperature that the wire can withstand. It is important to select a wire with an insulation rating that is appropriate for the environment in which it will be used. For example, if the wire will be exposed to high temperatures, you will need to select a wire with a higher insulation rating. When working with Class 2 wiring in heating, ventilation, and air conditioning systems, it is important to follow all safety precautions. Always disconnect the power before working on any electrical wiring. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to do the work for you. Electrical work can be dangerous, and it is important to take the necessary steps to protect yourself and others from harm. Also keep in mind that the NEC is updated every 3 years, so it is important to stay up to date with the latest requirements. The NEC is a comprehensive document that covers all aspects of electrical wiring and installation. It is an essential resource for electricians, electrical inspectors, and anyone else who works with electricity. By following the requirements of the NEC, you can help to ensure the safety and reliability of electrical systems. In addition to the NEC, there are other standards and regulations that may apply to Class 2 wiring in heating, ventilation, and air conditioning systems. These include standards from UL and other organizations. It is important to be aware of all applicable standards and regulations and to ensure that your Class 2 wiring installation meets all requirements. Proper grounding is also essential for Class 2 wiring in heating, ventilation, and air conditioning systems. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock. The NEC provides guidance on the proper grounding methods for different applications. It is important to follow the NEC requirements for grounding to ensure the safety of your Class 2 wiring installation. When installing Class 2 wiring, it is important to avoid damaging the insulation. Damaged insulation can create a shock hazard and can also lead to electrical problems. Handle the wire carefully and avoid sharp bends or kinks. If you accidentally damage the insulation, you should replace the wire. Proper labeling is also important for Class 2 wiring in heating, ventilation, and air conditioning systems. Label all wires and connections clearly so that they can be easily identified. This will make it easier to troubleshoot problems and to perform maintenance. Use a permanent marker or label maker to create labels that are durable and easy to read. In addition to the technical aspects of Class 2 wiring, it is also important to consider the aesthetic aspects. Make sure that the wiring is neat and organized and that it is not unsightly. Use cable ties or other fasteners to keep the wires in place. If possible, conceal the wiring behind walls or ceilings. A neat and organized wiring installation will not only look better, but it will also be easier to maintain and troubleshoot. When selecting Class 2 wire for heating, ventilation, and air conditioning systems, it is important to choose a wire that is durable and long-lasting. The wire should be able to withstand the environmental conditions in which it will be used. For example, if the wire will be exposed to moisture or extreme temperatures, you should choose a wire that is specifically designed for those conditions. A durable and long-lasting wire will help to ensure the reliability of your Class 2 wiring installation and will reduce the need for repairs or replacements. Finally, remember that Class 2 wiring is just one part of a complete heating, ventilation, and air conditioning system. It is important to consider all aspects of the system when designing and installing Class 2 wiring. Make sure that the wiring is compatible with the other components of the system and that it meets all applicable requirements. A well-designed and properly installed Class 2 wiring system will help to ensure the efficient and reliable operation of your heating, ventilation, and air conditioning system.